So now we'll try to find the area of some shapes. Okay, look at this rectangle that I have at the bottom of the screen. It has a length of 4 centimeters square and a width of 3 centimeters square. Now, to find the area of this rectangle, we count the boxes. How did we find the length to be 4 centimeters square? We counted the boxes along the length, and the boxes are 4. So 4 of them makes this 4 centimeters square. What about along the width? How many boxes do we have from top to bottom? We have just 3 boxes. So the area of the width, or the width rather, of this rectangle is 3 centimeters square. Now let's find the area. To find the area of a rectangle, remember we just said is length multiplied by width. So length multiplied by width will give us 4 times 3, and that's 12 centimeters square. If you take your time to count all the squares we have inside this rectangle, you will find out that there are 12 in number. Now, does a question come up in your mind? Why do we measure this in square centimeters? The reason is because look at the squares we have inside the big square. Look at the square we have, the squares we have inside the big rectangle, the actual shape. If you look at each of the small square, you will find out that they are of the same size. Each square is of the same size. So we consider each square to be 1 centimeter square. So if one square, that's the small square inside the rectangle, is 1 centimeter square, then if we add up all the other squares or count everything and then make a total of it, we will arrive at 12 centimeter squares. So one box or one square is only 1 square centimeter. 12 of them will be 12 square centimeters. Now I hope you understand the concept of counting squares or finding area by counting the squares. Alright, let's try to see another type of shape. What about if the shape is not covering all the boxes like this rectangle? This particular rectangle is covering all the boxes. Let's try to see another shape where all the boxes are not covered. Oh, before we do that, now please, before we go ahead to see that, I want to show you how you can divide your boxes into half. At times when the shape does not cover the whole box, the shape could cover up to half of a particular box. Because when you want to find the area of such shapes, what you do is you have to look at the boxes that the shape covers. How many boxes are fully covered by this shape? And how many boxes are halfway covered or more than halfway covered? To find out which boxes are up to halfway covered or more than halfway covered, let's see how we can divide each box. Now you see the red line that bounced in is dividing the box into 2 diagonally. Okay, so you can divide your box into 2 this way and see if your shape spreads into up to half of the box. You will understand that more when we go into the next shape. I can also divide my box in another way depending on the shape. I can check if the shape is up to half this way as well. That is, if the shape gets to this part of the box. I can check for half this way. Which other way can I check for half of the box or of the square? Let's see. I can split it into 2 vertically to check if the shape spreads into up to half of the box. Let's see another one. I can split it into half horizontally to see if the shape also spreads into up to half of the box that you're considering. And it can also be this way, or it can also be this way. So that means you can check if your shape is up to half in this ways. You can divide your box into two this ways to know if the shape gets into up to half or more than half. Now let us see another shape. Oh, but then I think I still need to let you know that, oh, I think we said that already, that the area of this particular rectangle is 12 square centimeter. All right, we mentioned that earlier. Now let's see another shape. I have a table. I have this shape. It's a triangle. Now look at this triangle. Some of the boxes are fully covered and some are not fully covered. Please bear in mind that the boxes we are considering are only the ones that are covered by the shape or where the shape reaches. All the other parts of this table, we don't need to bother ourselves with it. We only focus on the boxes inside the shape or where the shape crosses. All right. Now it's easy to know the boxes that are fully covered. For example, I have indicated on the fully covered boxes, I have indicated by writing F. So if you look at those boxes, they don't have a problem because they are fully covered. Okay, they are fully covered. The triangle fully covers them, so they don't have a problem. But what about the ones that have H? In most cases, the ones you may need to worry about are the ones at the edge of the shape. At the edge of the shape. Now let us check this triangle. Let's check the edge. You notice that it is at the edge of the shape that we have H, 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 because those boxes are not fully covered. But look at those boxes very well. Are they halfway covered? Yes, the boxes are halfway covered. Remember the first rectangle we looked at down here? And I said to you that you can check half of your box in this 1, 2, 3, 4, 5, 6 ways. Using these red lines, I showed you how you can check if your shape gets to up to half of the box. So let us look at the H on the right side now. All of the H you see there, the boxes or each of the boxes is split through the middle diagonally. Do you see that? Yes. So it means all the shapes, all the boxes at the edge are halfway covered. I mean at the right edge, they are halfway covered. So how do we now find the perimeter, the area? Let's move on to the boxes at the left hand side where we have H. Can you see that they are also split through diagonally at the center? Yes, that means those boxes are covered halfway. They are not fully covered. The triangle only covers half of those boxes. Now, let us see how we now find the area. To find the area of this one, we will need to add together all the fully covered and half plus half of the halfway covered. I will explain that to you. Now for the halfway covered boxes, look at only two out of them. Let's look at the two at the, no, let's look at the two at the right hand side of the rectangle at the bottom. Can you see? The two H we have at the bottom of the rectangle by your right. The first two we have from the bottom. Okay? Now, if you look at that half and the second half, if you add two halves together, you can get one full box or one full square. So what we are going to be doing in this case is, since each of them covers exactly half, what we will do is we will merge two halves together to make one full. So the two halves we have at the uh, bottom, we're going to merge them into one. So there we have one full. Now let's look at it upward. The next two halves we have, we'll merge it also into one to have one full square. So that is also one full square. Now we have made two full squares out of four halves. Let's check out the halves we have at the right or the left side of the triangle. Let's also take two halves and make it one full box. And the next two halves, we make it another one full box. It means we now have four full boxes or four full squares out of eight halves. We have merged two halves into one to make a full box. Okay, so let's now count together. The fully covered we have are 12. Now we have merged two halves into one, so we have been able to derive four full boxes with that. So how do we find the area? We add 12 fully covered, which represents the fully covered, with 4, which is h plus h equals to 1. That's half plus half makes 1. So that makes 4. 12 plus 4 is 16 centimeter square. So the area of this triangle is 16 centimeter square. Okay, but what about when we have a shape that is not like a straight line? It doesn't have straight edges like this triangle. Let's consider another shape. Here is our table, and let's have our shape. Look at our shape here. Our shape looks more like a leaf or like a drop of water. It is not having straight sides. How then do we find the area of a shape like this? Now, this is where you need to pay more attention so that you'll be able to understand how we get the area of shapes like this. Already I have labeled the F's, which represents the fully covered boxes, and I have also labeled the H, which represents more than halfway covered. Remember in the first rectangle that we saw, I showed you with the red boxes how you can divide each square into two to know if your shape gets to that point. That's to know if your shape gets to up to half of the box. Now for this particular shape, we'll be looking at a lot of edges. So please pay attention. Already we have the F's for the fully covered boxes, so we don't have a problem with the fully covered because the shape, which is like the leaf, has covered those boxes or the squares in the middle. So the squares in the middle don't have a problem. Those ones where we have F. Now let's look at the edges. This red line that just bounced in with the shape, can you see that we divided the box or those squares? We have two squares there, and you see those two squares are spreading into where we have the red line. So we're using the red lines to check if the shape is up to half of the square or not. For the two lines, of course you can see that the edge of the shape is not touching them, so it means the shape is not covering up to half of this particular two boxes, so we are not going to use that. Let's see another one. Now see the red lines that just bounced in. Can you see that they are splitting the shape or the boxes into two horizontally? Can you see that those shapes or the shape is actually getting to either up to half or more than half? Okay, it is reaching, or it is either touching the red lines or spreading more than the red lines. It has gone beyond the red lines or is touching the red lines. So we can say it is up to half. So we will consider those boxes as part of the area. That's why we have H. It's up to or more than half. H. We have the H there. Let's see the other edges. Look at these two edges. The first red uh, line that bounced in, this one to our left, that's beneath at the bottom, it's not up to half. We divided this shape into half vertically, but it's not, horizontally, but the shape is not getting to the line, so we don't use that. What about the second one? Of course, the shape is crossing the red line, so it has crossed more than half. We will use that. We consider it as more than half. Let's see other ones. Look at these ones at the left side where we have the H. Can you see that this shape is crossing, that's the blue lines, the edges of the shape is crossing more than half of those squares, the square boxes. So that means we will consider that part also for the area of the shape. And finally, I think we have some up there. Uh, these ones we just saw, the boxes, the lines that just bounced in. Definitely, the shape is not reaching up to half of those boxes, so we cannot use them. Let's see the top. Now look at the top. The shape is going way beyond those half of the shape, or pardon me, is going way beyond half of the box. Okay, so that means we'll consider them as half, more than half. All right, the one in the middle is actually fully covered, but the two at the edge, they are halfway covered or more than halfway covered. Now I hope you understand the concept of finding how far your shape has gone into the box, if it is up to half or more than half. All right, so with this now, can we find the area of this shape? Yes, the fully covered boxes are 20. If you count the number of F's we have 20 of them. What about the more than halfway covered? We have 10. So if you count the H, there are 10 of them. Yes, 10 of them. So what does that mean? It means that we can say that the area of this shape is 10 plus 20, which is 30 centimeter square. For this kind of shapes, because they don't have a regular straight line like the triangle, we make an estimate. Okay, so we can say that this shape should be about 30 square centimeter. I hope you understand this part of finding the area of shapes that have curved sides or irregular sides. All right, students, I think this is where we come to the end of this lesson. We've been able to understand how to find area by counting squares. Okay, we've refreshed our knowledge about finding area by counting squares. If you have any questions, please do ask on Class Dojo, and please make sure that you complete your workbook and the exercises we have in the student book. So till we have a lesson again next week, take care of yourselves, students, and have a great time. Bye.